The diagram shows a solid cone with a solid hemisphere. Like this is a solid cone and this is a solid hemisphere. The cone has a radius of 2.4 centimeters and a slant height of 6.3 centimeters. The hemisphere has a radius r. Hemisphere means half sphere. Now, the total surface area of the cone is equal to total surface area of the hemisphere. I mean, if you take the total surface area of this cone, that will be equal to total surface area of this hemisphere. Calculate the value of r. This one we have to find. So first, it is given that total surface area, for total surface area I will write shortly TSA. So what is given? It is given that the total surface area of cone is equal to total surface area of hemisphere. All right. Now, remember, it is given the curved surface area of the cone is given and curved surface area full sphere is given. But the formula for total surface area is not given. For a cone, if you remember, the formula for total surface area is always pi RL plus pi R square. This is the formula for the total surface area. This is L. The slant height is L. This is R, the radius. While for hemisphere, for full sphere, the curved surface area, total surface area is same. But for hemisphere, remember, if you will take that one, this will be 2 pi r square and then this 1 pi r square. Because you know, if you will take a full sphere, for full sphere, the total surface area will be 4 pi r square. For sphere, I'm saying three-dimensional case, just like a ball, for example. Like this usually the symbol for the sphere. But if it is hemisphere, then for hemisphere, the total surface area will be, look, for this one pi r square, 2 pi r square for this one, and 1 pi r square for this one. So total will be, as its radius is taken capital R, so I will say 3 pi r square. This is for hemisphere. If we will have full sphere, then it will be this one. So this difference in the total surface area you have to remember. Okay, clear? Yes, one more thing. Curved surface area of the hemisphere will be 2 pi r square, because this is the curved part and this is not the curved one, because it has curved and this one is flat. So that is why total will be 3 pi r square. For hemisphere, curved surface will be 2 pi r square, but total surface will be 3 pi r square. That difference hopefully you understand and will keep in mind. Now I think it will not be problem at all. Pi from both sides, take the common and you can eliminate it here. Get rid of it. Here, no need to keep with it. So pi, take common from this side, RL plus R square equal to 3 pi R square. So pi is same on both sides, will cancel. I am left with RL plus R square equal to 3 R square, because pi we cancelled. Now I want to calculate the value of R. So take 3 also to the other side. It will be RL plus R square over 3 equal to R square. Take the square root on both sides. So finally I made the formula for R. So R will be RL plus R square over 3 square root. That is. Okay, put the values. R, the radius of the cone, small r, 2.4. Multiply the slant height, this is L, 6.3. Plus R square, 2.4 square divided by 3. Okay, do calculation for this one. square root, then 2.4 multiply 6.3 plus 2.4 square divided by 3. So it will be 2.638. 2.638, and by rounding to 3 significant figure it will become 2.64 centimeters. So that is simple. Just I know many time I can see the student get confused with curved surface and total surface area. So of course the formula you have to remember. In case you find any difficulty, please feel free to ask me. Never hesitate in asking. So that is for the part A of this one. Okay. Now next we'll move to part B, obviously related to this one because this is paper 4, and in paper 4 write the value here 2.6 for finally rounded answer. All right. Now the diagram shows a solid cone with a radius of, now this is a solid cone with a radius of 7.6 centimeter and a height of 16 centimeters. This is the height, vertical height. This is not the slant height. This is a solid cone. A cut is made parallel to the base. You can see we cut it from here. So obviously this part has been removed. Now the remaining is this one. Calculate the volume of the remaining solid. Very interesting question. When you cut, so now this remaining height is 12 centimeters. So it means when you cut it, this small cone got separated also. Now whose height is, in this case, if I will say, its height is 4 centimeters. And what is its radius? That we need to find till now. Because we don't know what will be the radius of this one. Then we will be able to, if somehow we manage to find this radius, because this radius will be similar to that one, then we will be able to find the volume of the remaining solid. This volume of the full cone is given. So somehow try to find this radius. I will say if this is R1, let's say this radius is R2. Okay. So I have to try to find this. And for that, I can use, I think, similarity. Because if you look at that one, the bigger triangle, the bigger cone and the smaller cone, they are similar to each other. They are similar. So the property of the similar one will be, if you call this height as h1 and this height obviously say h2, which has been cut from this one. So as they are both similar, the small and the larger one has a height of 16. So the ratio in similarity, what we do, we know the ratio of for finding that also, I can go, there is one way. The formula of the volume is also given. We may use the formula of the volume as well here. Okay. Or alternative to that, for the top one, because the main concern here is finding the radius of the top one. Okay. So the ratio of the volume, if you remember the rule, the ratio of the volumes is equal to the ratio of the corresponding sides cube. That rule can be used here. Because if let's say the volume of this one is V1 for the big one, and the volume of the small one, let's say, is V2. So if you will say, it means that this large one and the small one are similar. So I can say V1 over V2. Their ratio will be any corresponding side you can take. You can say the ratio of R1 over R2 cube, R1 over R2 cube. So as I'm interested in finding a R1, so that's why better if I will go for this rule. Okay. R, instead of that one, I can go for the ratio of the corresponding heights also. Similarly, you can say it will be h1 over h2 cube also. So accordingly, we will use them. First, let's write the formula. V is 1 over 3, 4 pi r square h. So if you will write V1, it means V1 will be 1 over 3 pi r1 square h1. And if you write V2, it will be 1 over 3 pi r2 square h2. Yes. So if you will take their ratio, it will be like this one. First, I'm just considering this one, V1 over V2. So it will be 1 over 3 pi r1 square h1 over, forget this one because it without that even we can do. But in case if we need, we can do that also. We can go for the height as well because these are also correspondings. Over 1 over 3 pi r2 square over h2. That will be equal to r1 over r2 to the power 3. 1 over 3, 1 over 3, pi with pi, and this one will become, I can write it, r1 over r2 whole square, I can say here. So h1 over h2, or directly why I did not use the ratio of the corresponding side can also be equal. Sometimes we take the things a bit longer. This can cancel with 1. So h1 is equal to h1 over h2 is equal to r1 over r2. So that direct property also you can use. That h1 over h2 will be equal to r1 over r2 because the ratio of the corresponding side will be equal. And they are similar. So that can be taken from here. So I will say what is h1? 16 over h2, the second height, that is 4, equal to r1 is 7.6 over r2 we don't know. So we will try to calculate this one. That will become 16 over 4 is 4 equal to 7.6 over r2. You can replace them, cross multiplication. So r2 will be 7.6 over 4. So what that will be 7.6 divided by 4. So it will be 1.9. It means R2 is 1.9 that we found. I just did this calculation to show you how they can be equal also. If you don't want to do this calculation directly, remember, as both of these are similar, as this cone, smaller cone and the larger cone are similar, so in similar, the ratio of the corresponding sides can be equal. That R1 ratio R2 will be equal to H1 ratio H2, and that is what came here. So from that I found R2, the smaller radius now. It means if I know this radius now, this radius is R2. The remaining solid right now is a trapezoid, okay? And I want to find the volume of this one. Its height is given, and right now for finding the volume of the trapezoid. This formula is a little bit complicated. If you can remember directly, it can be. Otherwise, to prove it might be a little bit longer, but we can prove it. It's not difficult at all to remember. In that case, what we will say, you can say, now I have the smaller radius already, the larger radius and the smaller radius. Both the radius are there with me. Okay. So how I can find that one? The main thing was finding the smaller radius. So what will be this volume? Find the volume of the large cone. Find the volume of the small cone, because now you have the smaller radius also. Okay. Once you have the smaller radius, I will just erase this area. So the diagram will be in front of me, and I'm not going to use it anymore. I already used this one to calculate my R2. So simply what you can do now, find the volume of, what will be the volume of this lower part. Sorry, the volume of the lower part, if you have to find, how you can find the volume of the lower part? Find the volume. Sorry, I think I was disconnected, and I'm back again. Yes. So it was what we were talking about. We need to find the volume of this one now. So find the volume of the large cone minus the volume of small cone, simply. So this will give you the volume of the remaining solid. So we will say the volume of remaining solid will be equal to the large volume that we said is V1 minus the small volume, which is V2. So the remaining will be this lower part. Okay, so that will become V1. V1, I'm having the write the formula for V1. 1 over 3 pi R1 square H1 minus the volume of the small cone will be 1 over 3 pi R2 square H2. So 1 over 3 pi can be taken common. The remaining will be R1 square H minus R2 square H2. Sorry, H1 H2. Now just put the values. 1 over 3 pi is 3.142 into R1. The first radius is 7.6 into H1. Its height is 16 minus R2. This radius for the smaller cone we found already was 1.9 into H2. The height of the smaller cone that we cut is 4. So calculate this one. I will have 1 over 3 multiply 3.142 into 7.6 square multiplied by 16 minus 1.9 square multiplied by 4. So 952.78. 952.78 centimeter cube, that you can round to 953 approximately. So simple. The main thing was we cut apart from this one. So to find, actually I was looking for find the radius of this part, and for that I used the property of the similarity. Then from the large cone I subtracted the volume of the small cone and got the volume of the remaining solid. Okay. Question number 4. The exchange rate is €1 is equal to $1.142. Okay, that is €1 is given $1.142. Johan changes $500 into euro. Calculate the number of euros he will get. So he has $500. He converted into euros. We don't know how many euros we'll get. So let's say he gets X euros. So find the number of euros correct to the nearest euro. So cross multiply. It will be X into 1.142 equals to 500 multiplied by 1. So X will be 500 divided by 1.142. Okay, so calculate 500 divided by 0.142. So 437.82. If I will round this, because I have to get to the nearest euro, mean decimal part we don't need. It will become 438 euros. That was. So as we know, currencies are always directly proportional. So if the currencies are directly proportional, so this method we can use easily for them. No problem will be there. Okay, John buys a computer for $329. The same computer costs €275. Calculate the difference in the cost in the dollars. Okay, we have to calculate the difference of the cost in dollars. I mean, this time he bought in dollar, already we know 329. In euro is 275 euro. So convert 275 euro into dollars. Okay, as we know, 1 euro is $1.142. 1 euro is equal to 1.142 dollars. So now having 275 euros, how many dollars will be? Let's say y dollars. So cross multiply. What will be? I will have y equals to 1.142 into 275. So we will get 1.142 into 275. We'll get 314.05. Now we want the difference. Look, if he was buying in dollars, was this one in euros, it was equivalent to this one. So what is the difference now? So the difference will be the higher cost minus lower cost. So that will be 15.05, that you can round to the nearest dollar will be 15. $15 will be. All right. Now next is part B. Lucy spent 3/8 of the money she has saved this month on a book that cost $3.25. Calculate how much money Lucy has saved this month. Mean it's given 3/8 of total she was having this month. She bought the book whose cost is $5.25. That book is 3/8. So it means 3/8 of the total is given is 5.25. So what will be total of mean multiplication? So it will be 3/8 times total equal to 5.25. So what will be total? You have to shift it to the other side. It will become, total will be 5.25 into, when you will shift this to the other side, it will reciprocal 8/3. So what will be 5.25 multiply 8 divided by 3, so 14. It means she was having the $14 as saving that was spent on buying this book. All right. Basic finance, quite easy. Part C. Komal invests $6,130 at R% per year compound interest. Compound interest. What is invested? That is principal. This R is the rate of the interest for compound interest. The value of his investment at the end of 5 years, time duration, and value of the investment mean the amount. Calculate the value of R. So this time you will use the formula for the amount of the compound interest. Now the formula for the amount of the compound interest is A is equal to P into 1 plus R over 100 to the power T. This is the formula for the amount of the compound interest. P into 1 plus R over 100 to the power T. Now amount is given. Amount is 6,669. So write 6,669 equal to the principal is 1,130 into 1 plus R, the rate we don't know, over 100 to the power T. Time duration is 5 years here. All right. Now we want to find this R. So first take it to the other side. It will become 6,669 divided by 6,130 equal to 1 plus R over 100 to the power 5. Now take the fifth root on both sides. because to finish the power 5 first, I will be left with now 1 plus r over 100 equals to the fifth power. Don't calculate this at one time. I will calculate at the end. 600, 130, fifth root. Then take 1 to the other side. So I will have here r over 100 will be equal to the fifth root of 6669 over 6130 minus 1, because this 1 is shifted on the other side, and this 100 finally will make 100 into the fifth root of 6669 over 6130 minus 1. So let's calculate that. 100 into the fifth root, I can write in this way, fifth root of what? 6669 divided by 6130 minus 1. Calculate that, you are getting 1.699. That I can make 1.7% by rounding 1.7% approximately. So finance question, quite easy. If you remember the rules of the finance, the formulae that were taken during the detailed course, still detailed course videos are available. You can go for them as well. Okay, this one probably is looking like a trigonometry question where the triangles are involved. The diagram shows the triangle ABC. X is the point on BC. AX is given, XC, so you have to calculate the length of AC. Okay, we want this length. Now to find this length, if I consider this triangle, just consider this triangle. AXC. This is 6.4. This is 10.6. This angle is 78. So what this angle will be? 180 minus 78, because total angle with the line should be 180. So this will be 180 minus 78. That will be 102. That means this angle is 102. So I want to find this side. Cosine rule can be used. This side is this is x, so the side opposite to that one you can say small x. This is a, so opposite to that small a. C, so opposite to that small c. So how I can use the cosine rule? For the side opposites will be square root of sum of square of the two sides. Just recall the cosine rule. Minus 2 AC, multiply them, cos of the angle that is to the opposite side, that is 102. If you just recall quickly the cosine rule, that if you have the triangle ABC and this is A, this is B, this is C, so how do we find A? A will be in this way, square root of B square plus C square minus 2 BC cos of angle A. So this is what I'm applying on the same triangle. And it's pretty easy. Put the values in. A is 6.4 plus C is 10.6 minus 2 into A is 6.4, C is 10.6, cosine of 102. Plus calculate, and make sure your calculator should be in the degree mode. That is because all our IGCSE calculations are in the degree. Minus 2 into 6.4 into 10.6 cosine of 102. So 13.47. That I can round, so we'll get 13.5 centimeter. That was our first part where we were asked to find AC. So we found AC using cosine rule. Then in part B, you have been asked to calculate BX now. Okay, we want to find this BX. For finding the BX, I will consider this triangle. I will take this triangle, which is, this is B, this is X, and this is A. ABX triangle I will take. Two angles I know, this is 58. This angle is 78. And I can find the third angle. One of the side is also given, 10.6. I want to find this side. I think let's find the third angle first. What this third angle will be? The third angle will be 180 minus other two angles. Because then it will be easy for us to apply the sine rule. 58 minus 78. So 44. This angle is 44. We found this angle. Now once we found this angle, then let's say this is A, this is opposite B, this opposite is X. So I want to find this side. So I can say A over sine A, okay, A over sine A equal to B over sine B, sine B. These two are enough. C over sine C, no need, because we are not finding this one. In case if you need, then we can, but right now we don't need that. So I will say this one is A. A is what I need to find. This is BX actually. Over sine of A means sine of 44 equal to B 10.6 divided by sine of B, sine of 58. So what will be BX? I will shift it to the other side. So finally BX will be 10.6 over sine 58 multiplied by sine 44. So let's calculate that. 10.6 divided by sine of 58 multiplied by sine 44. 8.62. It's 8.62 centimeter. Simple. Then calculate the area of the triangle ABC. For this full triangle ABC, I have to find the area. Now this side I found is 8.62. Okay. For finding the area, obviously I need, I can do two ways. I can find the area for this triangle separately, area for this triangle separately. Okay. And then it can be. But that we will do in our next part. Okay.